When we think of black holes, we often imagine them as giant cosmic vacuum cleaners that suck everything in. But the truth is more fascinating. Black holes don't just absorb matter. They create a rhythm. This rhythm isn't simply noise, but a structured beat, akin to the sound of a drum that reverberates through space. What makes this rhythm so interesting is its consistency, clarity, and the way it seems to echo a kind of emotion, reflecting the immense forces at work inside the black hole. According to the energy filament theory, the origin of this beat lies within a core structure known as the piston layer. This piston layer is not just a solid outer shell, but a layer of muscle-like tension that contracts and expands, propelling energy out in waves. Each time it contracts or relaxes, it produces an invisible, rhythmic pulse that spreads outward through the fabric of space. To visualize this, think of a giant low-frequency speaker. Inside the speaker, the diaphragm doesn't need to touch the outside world to generate vibrations. As soon as the diaphragm moves, it sends waves of energy through the air, which can be heard from great distances. In the case of black holes, the piston layer acts like this tension membrane. The core of the black hole, which is in constant motion and turmoil, generates waves of tension. These waves first collide with the piston layer. The piston layer then works like a speaker diaphragm, organizing the waves into pulses and sending them outward towards the black hole's event horizon. As we've discussed in previous episodes, the event horizon is the boundary of the black hole where light and matter can no longer escape. It's not just an abstract line, it's a physical boundary that vibrates with tension. When the pulses from the piston layer reach the event horizon, the boundary reacts with tiny pores that open and close. These micro-oscillations imprint the rhythm of the pulses on the surrounding space. In essence, black holes don't just flash randomly, as some might imagine. Instead, they pulse with a regular, predictable rhythm. The energy jets, which are often seen shooting out from the poles of the black hole, don't randomly burst in any direction. They are carefully shaped, their direction fixed, as though following a steady, musical beat. Even the brightness that we observe from distant black holes, the so-called black hole shadow, can be understood in terms of this rhythm. The light we see may not be from the black hole itself but from the interactions of the particles around it. As these particles are pushed along by the rhythmic tension of the black hole, they create observable patterns. These patterns can look like regular peaks and valleys, almost as if they are choreographed by the black hole's internal rhythm. The rhythm of the black hole, however, is not just a superficial characteristic. It is a direct result of the black hole's inner workings, especially the piston layer. It takes the chaotic churning within the core and transforms it into a steady, consistent beat. This rhythm is then transferred to the space around the black hole through the event horizon, creating the regular signals that we can detect through our instruments. In larger black holes, the rhythm is deep, slow, and measured, like the tolling of a massive cosmic bell. On the other hand, smaller black holes exhibit a quicker, more frantic rhythm, akin to the rapid beat of a hand drum. In conclusion, the rhythm of a black hole is not a random phenomenon. It is a direct result of the black hole's internal tension mechanism, which manifests itself as a pulse that resonates throughout space. This rhythm is a key feature of black holes and is what gives them their personality in the universe. Whether the black hole is large or small, the rhythm is a defining characteristic, and the greater the black hole, the more controlled and stable its rhythm becomes. In the next episode, we will explore, how do black holes process information, and can they even rewrite it? Tap follow, share it on New Physics, Clear Universe.